All right. Good morning. I hope the exam went well. I had 15 people who sent me messages to look at the exam. So once again, make sure that you know how to enter results on the online exam. Make sure you know what you're doing with the online exam, because I'm not going to be real lenient about this. And so I do expect you to know how to enter things. Obviously, if the computer's being real meticulous about points on a graph, I'm not going to hold you accountable for things like that, but I am holding you responsible for knowing how to input information into the online exam. That's part of what we're doing here. So different than any other years, I mean, not only you're required to understand the content, you're required to know how to work these online programs, in this platform. So anyhow, but anytime you send me a message to check something out, I don't want you stressed out about it. I don't mind looking at it. So if you think that the program's not working right or something, I'm happy to take a look at it. All right. So yeah, I have not looked at the exams at all. Today I plan on teaching a new lesson in the new module. And it's lesson 13.1, which has to do with exponential growth. And this is something that you should have extensively studied in Algebra 1. So I'm hoping that this doesn't look like new material to you, that you do know about exponential growth equations, functions. And so anybody have any questions about anything before we get started on this new lesson? No? Okay. So I don't, I keep my folders of notes upstairs in my library. So this leads me to believe that if this is the exponential growth functions, 13.2 is going to be the exponential decay. And the main thing is you're going to have to know how to graph these using transformations. And so it's kind of just a review of things you've already learned. So this is California Content Standard F-BF.3. I do have a note to make sure you do the Explorer. And the first objective is we're going to be graphing combined transformations. So in other words, they're going to be more complicated than transformations we've had in the past because you've had transformations extensively in here thus far. So combined transformations. Of the parent, b to the x. So I'm going to give you the form and then explain what's going on. First of all, I'm going to give you the form that I would give you if I wrote the book. So that's the form I would give you. And the standard says that students know what A, B, H, and K do to the parent. So take one guess what A does to the graph.
Translate it to weekly.
Say that again.
Translate it to weekly.
Yeah, it's a vertical transformation. Translate would be H or K, but it is a transformation, vertical, or it's a vertical stretch or compression. And it also reflects over the x-axis. Take a guess what B up there in the exponent does.
Horizontal transformation.
Yeah, it's a horizontal stretch or compression and a reflection over the y-axis. H up there, left or right, K up or down, believe it or not. It's like, how could this possibly work? You know, we have the vertical stuff down below and we have the horizontal stuff in the exponents. Now, this Z is the parent. And that's what's going to be different than the quadratic, the cubic, the cube root, the absolute value, is that the parent's different with all these. So you don't need to write this down. I'm kind of just leading you into it. You could have a parent like 2 to the x, 3 to the x, 4 to the x, 5 to the x. So those would all be their parents. They're not vertical anything, they're parents. So these guys represent exponential growth. If you have 1/2 to the x, 2/3 to the x, 7/8 to the x, those are going to be exponential decay. So the growth is going to go up and the decay is going to go down. I'm going to explain this, so you don't need to write it down. I'm just giving you the heads up that the parents are going to be different. So that means if the parents are different, all your parent points are going to be different depending on the base of the exponent. So the book doesn't give this to you. So what the book gives is this. So I just want you to know this B, it's not a horizontal stretch of compression, that's the parent. And in all these problems you do, the actual B up here, it's being multiplied to the X, they're not giving you it. The B's 1, so you don't need to worry about it. So I don't know if they're afraid to give it to you. I'm not sure if they don't know what's going on with it, but I'm just letting you know that if there's a number in front of it being multiplied to this X, that's a horizontal stretch of compression and a reflection across the x-axis. This B, the way they have it in the book, is the parent. Okay? All right. So let's take a look at the graph of a parent. I'm going to erase this, okay? You have it written down. Now, here's the condition. This is where B is greater than 1. So in other words, the parent can't be a 1. It's got to be greater than 1, like 2, 3, 4, 4.5, 4 and 7/8, 8/5. So exponential growth, I'm going to show you in a minute, it goes up, and the base of the parent has to be greater than 1. So the next lesson I teach, when I talk about exponential decay, this B is going to be between 0 and 1. In other words, it's going to be a proper fraction. So the graph is going to fall. So I'll say it again. Anything greater than 1 is going to be exponential growth. Even if it's an improper fraction like 8/5, that's exponential growth. Anything that's between 0 and 1, like 1/2, 7/8, 2/3, that's going to be exponential decay. All right, so let's take a look at a parent. Let's take a look at 2 to the x. Okay, that is definitely exponential growth, and it looks like this. It actually has a horizontal asymptote that starts at y = 0. And I'll just let you know, if you have a k that moves up and down, it will move the asymptote up and down. All right, so let's just look at this parent. What does it look like? The parent points, that's the asymptote. I would pick simple, I would always pick 0 because 2 to the 0 is 1. And then I would pick 1. So 2 to the 1 is 2. Now notice that if this was 3 to the x it would still be 0, 1, and it'd be right 1 up 3. If this was 5 to the x, it would be 0 up 1, and this would be right 1 up 5, right? All right, so when you graph this guy, you're going to always draw the asymptote, and the asymptote is the line that the graph approaches indefinitely and closely without touching it. And you just graph these points, 0 up 1, right 1 up 2, and you draw the graph up, running along the asymptote. So like I said, this is exponential growth. If they're going to ask you to write domain and range, the domain is always left and right forever. And the range would be open on 0 up forever. All right, so let's do a more complicated problem now. So like I said, they're gonna throw some hefty transformations at you because they believe that you already know what you're doing with these. All right. So I'm going to work a few problems. I'm going to work a regular problem. I'm going to work one with decimals, and I'm going to work one with fractions. So you have a variety. All right, here's the first one. I'm not going to write down the directions. I'm just going to circle what they're asking for, and this would be a heavily weighted problem on an exam. So they're saying g of x is equal to -3 times 2 to the x minus 2 plus 1. So the first thing we're going to do is we're going to take a look at the parent points, and then we're going to do the transformation in the correct order, which is going to be form 1. So here we go. So the parent is the base of the exponent, 2 to the x, and it is the most basic graph, as usual. So we just looked at this. We know that there's a horizontal asymptote at y equals 0. And so if I pick 0, 2 to the 0 is 1, pick a 1, write 1 up 2. Okay, that's the parent. And we do know that exponential growth goes up. Now, the reason why I'm drawing that is because we have a reflection, right? So this graph isn't going to look like this at all. It's going to reflect and look like that, correct? And I'm going to put these pictures over here because I'm going to use that space below. You guys with me so far? It is important to draw these little sketches because you're only graphing 2 points. So you have to have an idea what the graph looks like. Otherwise, you're not going to be able to graph 2 points. So let's state the transformation first. There's a lot going on here. So do you guys, someone tell me the order of transformations that you have to follow? Because if you don't, you're going to get the wrong graph. So what is the order?
Translate left and right, stretches and compressions, reflections, then translate up and down.
Thank you. All right, so here we go. So what are we doing first? Let's go. Someone besides Alessandra. I know she knows what she's doing.
Do we do left 2 first?
It's actually right 2 because remember minus is in the form. So it's right 2, just like all the other ones we did. Do you guys remember that? That the minus is in the form for remember the quadratic? X minus 3 quantity squared was right 3. Same thing. Nothing's changed. All right, next.
Horizontal stretch 3.
Is that a horizontal stretch or vertical? It's a vertical stretch by 3. Go ahead, I'm listening. Somebody else besides Alexis, Eddie, and Alessandra?
Reflect over the x-axis?
Yes, thank you. Reflect over the x-axis. Good. And one more.
Up 1.
Thank you. Good job, guys. All right, here we go. So I'm going to erase this up 1 so I have room, and I'm going to put it over here. All right, here we go. So the first thing we're doing is a right 2. And remember, right, left, up, and down is translations. You learned this in geometry. I know you did because you had Miss Fresco. And a translation is like taking your hand and moving an object. It doesn't change its shape. It just moves it. And that's what left, right, up, and down does. So right means add 2 to the x, add 2 to the x, and the y stays the same. The next is a vertical stretch. A vertical stretch is a transformation. It will change the shape of the graph. Remember our math aerobics where a vertical stretch means this? We're stretching it up. Okay, so we're going to multiply by 3, the y. So multiply by 3, multiply by 3. The next one is reflect over the x. That's a vertical movement. Watch my arm. So we're going to negate the y. Negate the y, negate the y. And last but not least, another translation, which is up 1. So we add 1 to the y, add 1 to the y, and now we're ready to graph. Hold on though. Did our horizontal asymptote change? Who moves a horizontal asymptote? Is it A, B, H, or K? It's going to move a
K.
horizontal asymptote. Say that again, please.
K.
Yep. So who is our new asymptote?
One.
Y equals 1. It's a line. So y equals 1. So we're going to draw the line and make sure you don't draw a line segment. It is a line, so make sure you put arrows on it. And we're going to graph the points. So we have right 2 down 2. And we have right 3 down 5. And do you see how we would be completely lost if we didn't have the asymptote and if we didn't know what this looks like? Like, what are we drawing? Are we drawing this way, that way, up, down? How are we drawing? Remember we drew this? Remember this? So we're gonna run this graph along the asymptote and down, and that's our graph, which does look like this, by the way. What's our domain?
Forever left.
Negative infinity to positive infinity.
Forever left and right. Good, Angel. And then what about the range? Now, at the beginning of the year, we got really confused about how to write this. Remember, the smaller number has to go on the left. So who's the smaller number?
Negative infinity.
Up to what?
Positive 1.
Right, open. Okay, so let me tell you what they asked for in this problem. They asked for the domain and range, which you're responsible for. They asked for these points. They're calling them reference points, but I'm not teaching like the books. I'm just letting you know that this may not correspond to the book. And for an exam, I wouldn't hold you accountable for what the book's doing. I'm holding you accountable for what I'm doing. The next thing they wanted was the asymptote. And let me assure you, if you put a 1, it's going to mark it wrong. It has to be y equals 1 because it's a line. And then they're asking for the graph. So they want the domain range, they want the reference points, the asymptote, and the graph. So a lot of stuff. All right, anybody want to ask me any questions about this problem? All right, let's do another problem now. This one has decimals. So technically that means you can use the calculator. Not to graph. You have to graph by hand. But you can use the calculator to multiply or add numbers. All right, this is 1.5 times 10 to the x minus 3 minus 5. All right, first of all, who's the parent? Who is the most basic graph?
10 to the x.
Yes, good job. All right, so 10 to the x, and we know that we have a horizontal asymptote at y equals 0. So what x's are you going to pick? You can pick any x's you want, but which ones would I pick?
0 and 1.
0, 10 to the 0 is 1. I'm asking for x's. I'm not asking for an ordered pair. I'm asking for x's. What other x would you give me?
1.
Right, 10 to the 1 is 10. All right, so over here, we know that this is exponential growth, and there is no reflection, so it's going to look like that. All right, here we go. So state the transformation, please, and can you guys take turns, please, telling me what the transformation is?
Right 3.
Right 3, good job. Somebody else? Now, a lot of times students want to include the parent in the transformation. The parent has nothing to do with the transformation. That is not a vertical or horizontal anything. It's not left or right. That is the parent. Okay, so go ahead. I'm listening.
Vertical stretch by 1.5.
Vertical stretch by 1.5. And what else?
Down 5.
Down 5. Good job. All right. Okay, so here we go. So right 3 is a translation. So right 3 would be 3, 1. And right 3 would be 4, 10. If you wanted to explain this to your little brother or sister in the future, you could show them this code, right 3, above the arrow. The next one's going to be a vertical stretch. So we're going to multiply the y by 1.5. So 1.5 times 1 is 1.5. And this is 1.5. Anytime you multiply by a 10, you move the decimal right one place. If you multiply by 100, you move the decimal twice. If you multiply by 1,000, you move the decimal 3 times. So I'm not going to use a calculator. I'm just going to say 1.5 times 10 is 15. So the next is down 5. That's a translation. So you want to be careful here. You have 1.5 minus 5.0. So you're going to switch those so you can actually subtract if you had to do it by hand without a calculator. So that would be depends, and opposite subtract would be what? $3.5? Yes, no? Got to line up the decimals, right? So negative 3.5 and subtract 5 from 15 is 10. Okay, if you did not have a calculator, you guys do see what I'm doing, right? I'm taking the bigger number minus the smallest, but it is negative. And I'm lining up the decimals when you add or subtract. All right, did anybody move the horizontal asymptote? Who moves the horizontal asymptote?
Okay.
Okay, thank you. So what is our new horizontal asymptote? Y equals what?
-5.
So I'm going to draw that 1, 2, 3, 4, 5. And you are going to draw a dotted line with arrows. All right, so we're going to go right 3, down 3.5. And we're going to go right 4, up 10. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, 4 up 10 is way up there. And we know it should look like this, right? So it's real steep, very steep. And that's because the parent was 10. So this guy is going along the asymptote, and then he goes just almost straight up exponentially. All right, so what is the domain? Domain. Is this going straight up, or is it going to the right? Slightly, slightly, slightly.
Slightly to the right.
Okay, so what's the domain? All real numbers. What's the range?
-5 to positive infinity.
-5 up forever. That is correct. So they are asking for, once again, they're asking for the domain and range. They're asking for the new asymptote. They're asking for the graph, and they're asking for these points after the transformation of the parent. Okay, so this was the problem with the decimals. Now we're going to look at one with fractions. Anybody have any questions so far? It's kind of, I mean, it's what we've done before. Yes, we have an asymptote now and a new graph, but it's the same thing we've done before. Oh, they give us a 10 again. All right, who's the parent? Most basic graph.
10 to the power of x.
So the points are going to be the same as the last problem. So we pick a 0, 10 to the 0 is 1, pick a 1, 10 to the 1 is 10. All right, we know that this is exponential growth and it's going up, but what does this do?
It reflects.
Over the x-axis. So it's not going to look like that at all. It's going to look like that. So the first thing is what? Is that left or right?
Left.
Left 2. Then what?
Vertical compression by 3.
Vertical compression by 3/5, and then a reflection over the x, and then what?
Up 3.
Up 3. All right, so here we go. So the first one is left 2, that's a translation. So left 2 and 0 would be left 2. Left 2 and 1 would be -1. The y stay the same. Vertical compression means multiply the y by 3/5. So we're going to multiply the y by 3/5. Multiply the y by 3/5. Isn't that 10 over 1 times 3/5? So what would that be?
6.
6. Because you're going to cross cancel, right? Right? You're not going to say 30 over 5. Hopefully I've convinced you not to do that. So you're going to cross cancel. 2 times 3 is 6. Then we'll reflect over the x as a vertical movement. So we're going to negate the y. Negate the y. And so the x stays the same. And up 3 means, watch, we have negative 3/5 plus 3. Well, don't you need a common denominator? Yes or no? So what do you get? What do you get?
12/5.
12/5. And then up 3 with that would be a negative 3. So remember how to change this improper fraction to a mixed number. 5 times what is 12 and put the remainder on the top would be 2 2/5, correct? 2 2/5? 2 out of a whole 2 and 2 out of 5 parts. You go left 2 and you go up 2 and 2 out of 5 parts. Then left 1 down 3 and did our asymptote change. So our parent was y equals 0. Do we have a new asymptote or not? Who moves the asymptote?
Okay.
So our new asymptote is y equals 3. And we know the graph looks like this. And we know because the parent is a big number that it's going to go down sharply. So what's your domain?
Forever left and right.
Mm-hmm. And what's your range?
Negative infinity to 3.
Open, because you can't hit the asymptote. All right, now that was nothing new, and you can probably guess what's coming up next. You're going to have to write equations given a graph. So same thing we've done in the past. These are a little more complicated, but it's the same concept. Anybody have any questions about this problem? All right, so they're going to ask you to write an equation. And they're going to give you information. They're telling you the parent is 2. That's the parent. And I would write down the function. It's a times b to the x minus h plus k. And just like before, we're going to find a, b, h, and k, but this b is not a horizontal stretch or compression. The b that they're asking for now is the parent. So they're giving us the parent being 2. All right, let me draw the graph. So in this graph, you have a horizontal asymptote at y equals 1. What does that tell you? Does that tell you about A, H, or K?
It tells you K is 1.
That's correct. So we know K is 1 by the asymptote. All right, the other points they give are kind of crazy. They give left 1 out of 3 parts, down 1 out of 3 parts. And they give right 2 out of 3 parts. So 2 out of 3 would be 2 out of 3 parts, and down negative 5/3, which is negative 1 2/3. So listen carefully. There are numerous equations that you could write that would represent this graph. It's just a manipulation of numbers. So I'm just going to show you an easy way to do this, okay? All right. What I would do is I would pick the point closest to the asymptote. So I choose negative 1/3 and negative 1/3. Now watch what I'm going to do here. I'm going to kind of cheat. And I'm going to make my h, I'm just going to force my h to be negative 1/3, which is going to be this x coordinate. Now I'll show you why in a minute, okay? So that's the key thing to doing this my way, which is the best way. You pick the point closest to the asymptote, and you make the h the x coordinate of the first point. Now watch why I did that. We're going to find a. So we have our new function. This should be g of x, by the way. So we have g of negative 1/3, which is your x, is equal to a times the parent to the x, which is negative 1/3, minus h. Now, do you see why I did this? You see how I'm forcing this to be a 0. So whenever you pick the closest point to the asymptote and you use x to be h, this power is going to be a 0 because negative 1/3 plus 1/3 is 0. And then this would be plus k. So we know that this represents y, which is negative 1/3. And this would be a times 2 to the 0 power plus 1. So we know that a to the 2 to the 0 power is 1. So this is a plus 1 equals negative 1/3. Right? Now listen, you can subtract 1 and get a common denominator, but watch what I'm going to do. Watch what I'm going to do. I'm going to multiply by 3, multiply by 3, and multiply by 3. So in other words, I don't want to mess with fractions. So you get 3a is equal to negative 4, which means a, if you divide by 3, a is equal to negative 4/3. Now, you do not have to do that The reason why I did that is because I only want to mess with the fraction at the very end. I don't want to have to get a common denominator. I don't want to have to mess with fractions. So if you multiply by this, the whole equation by 3, you don't have to mess with the fractions until the very end. All right, so we're done. So our new function then, which represents that graph, is -4/3 times the parent to the x minus a -1/3 plus 1. And so my final answer is g of x is equal to -4/3 times 2 to the x plus 1/3 plus 1. Now, if you wanted to check this, you could put this on the calculator and define the window the way I defined it. Or let me show you another way to check it. Okay, do you guys have any questions about this part? I'm going to do another problem, but do you have any questions about what I did here?
H equals -1/3.
Say that again.
How did you get H equals -1/3?
Okay, I'm letting this x coordinate equal h to force this to happen right here.
Okay.
Okay? You'll see me do it again in the next problem. I'm going to do the same exact thing. Okay, let me show you how to check this. Now, you do not have to check only if somebody's betting you, or you need to have it right for an exam. Can you check? Watch this. You're going to take the second point, which is 2/3 and -5/3, and watch what I'm going to do here. I'm going to take our function that we came up with, and wherever I see an x, I'm going to put 2/3. This is y, right? This is y, correct? So I'm going to put -5/3 in there. Remember, when you do a check, you keep the left side on the left side and the right side on the right side. So check this out. This would be -4/3 times 2 to the 3/3 is 1, plus 1. And now, wouldn't this be -8/3 plus 1, get a common denominator? We don't want to get rid of the fraction now because we're proving it. We're doing a check. So you could bet someone $1 million this is correct, because there's no way we could accidentally come up with this. So this equation absolutely works. So they could ask you for the domain of this. The domain would be all real numbers. And the range would be -infinity up to 1 open. Okay, let's do another problem with decimals. Any questions about any of the basic math in here? Okay, can I erase this? Yes, can you respond, please? I can only see so many people. Questions about this? Hello?
How did you get -5/3 on the left side?
Well, remember this is g of x, and g of x is a function name, which means y.
Oh, okay.
So inside is x, but g of x is y. So I took that notation out and put in y because this represents y.
Oh, okay. I see. Thanks.
Okay, we're going to do the same exact thing in a different problem. So they want us to write an equation. This time they tell us the parent is 10. And we have g of x is equal to a times the parent to the x minus h plus k. And once again, we want to know what a is. We know the parent is 10. That is not the stretch or compression now. That's the b that we're used to is a 1 in these problems. So in this one, we have a horizontal asymptote at 6. So what does that tell us? A horizontal asymptote at 6.
K is 6.
K is 6. All right. So they give us left 4, up 4.4. So that'd be 4/10. So 4 out of 10 parts. And they also give us left 3 down 10. So left 3 way down there. And this graph is doing this. It's not going, that is not flatlining, by the way. It's not going completely vertical. It's always going to the right. Okay, so like I said, this point right here is -4 and 4.4. And this point down here is -3, -10. Now, if you're wondering, can I use this other point to do the equation? And the answer is yes, but listen to me. There are multiple equations, and if you really want to confuse me on an exam, give me a bunch of different equations because I'm going to think they're wrong and I would have to go through and check them all by hand. So what I'm asking you to do is I'm asking you to pick the point closest to the asymptote for your x and y. Pay attention. You're going to let h be -4, which is the x value, and we're going to find a. So we have g of x, g of -4 is equal to the parent, a times the parent, and we're saying x is -4 minus h. So once again, see what I forced? A 0 plus 6. So whoever was asking me earlier, this notation is a function which represents y. So we're going to take that out and put 4.4 in. And this ends up being a times 10 to the 0, -4 plus 4 plus 6. So we get 4.4 equals 10 to the 0 is 1, a plus 6. And so what you have here, you're going to subtract 6.0. And when you line up the decimals, you get a negative, what is that, 1.6? I know. It's okay. It's okay. So what's the function? A times the parent to the x minus a -4 plus 6. So our final answer is -1.6 times the parent to the x plus 4 power plus 6. So without doing a lot of math, I'm showing you the easiest way to do it when you pick the point closest to the asymptote. And you use the x value to be your h. So let's do a check because I am done for today. I do have a objective 3 to teach, and it's modeling, but you've taken an exam and did this lesson, so I'll save that for later. So I just erased it, but the other point is left 3 down 10. So we can use that to check this out. So we came up with negative 1.6 times 10 to the x plus 4 power plus 6. You're going to, for x, put in negative 3. It's negative 1.6 times 10 to the negative 3 plus y value, and the y value here is negative 10, so substitute that in, and you get negative 1.6 times 10 to the first power. And remember what I said earlier, when you multiply 10, it's like moving the decimal one place to the right. So that would be negative 16 plus 6, which is negative 10. So this is absolutely the correct equation. Okay, now, I did not sign the book work yet because Mr. Burnt made up this sheet that I really like. And so this is going to be graphing exponential functions worksheet. And so on these first problems, what I would do is I would graph and then select the correct graph. And on these next pages, this says initial amount. I don't know what he means by that. So you're just going to skip those. But all of this other information I really like, and that's why I'm using this. He's asking for, is it growth or decay? Who's the parent? Here's a table. I would just put your two values and I would make up a whole table. Write down the transformation, write the domain and range, write the y-intercept. Now you guys know how to find the y-intercept, right? Whenever you set x equal to 0, you can find the y-intercept in linear, quadratic, anything you look at. So when you set x equal to 0, you can find the y-intercept, and then they're asking for the line of the asymptote. And so there's a bunch of pages of these, and I think it's a really good review. All right, anybody want to ask me about any of these characteristics that we're asking for on this page? All right, well, class is over today at 10:45. So we do have some time. I want you to go under Math Wizard teams and start on this together. And I'll be around if you have any questions. All right, we will not report back because we don't have a lot of time left. We're just going to be working in the teams for the rest of the period. All right, any questions about this or the assignment or anything? All right, well, listen, have a good day, and I'll see you in your Math Wizard teams. I'll be taking attendance. Thanks, guys. I'll see you there.